All right, today we are going to solve systems of equations using substitution, and we're going to start with this warm-up. So at any time, please pause the video so that you can get a chance to do the warm-up, either with the printed out note sheet that I provided for you or on your own piece of paper. So if you would, let's start by pausing the video and trying the warm-up, problems 1 and 2. When you are finished, play so that you can watch me go over it. All right, so you should have tried 1 and 2. In problem 1, we're using substitution here when you're given 4x plus y equals 1, and the directions say find x when y is 2. So if y is 2, I can just substitute that 2 in for y, like so, and then I can solve. So I'm going to subtract 2, divide by 4, and x is equal to negative 1/4. All right, in problem number 2, you're given the same thing, 4x plus y equals 1, but now we want to find y when x is 3. So I'm going to take that 3 and I'm going to substitute it in for x. So wherever I see an x, I substitute a 3. And go ahead and solve. This is 12. Subtract 12 from both sides. And y is going to equal negative 11. All right. The next thing on your note sheet is just a little bit of a review showing us that in the past we have solved systems of equations by graphing. So remember, a system of equation is when you have 2 or more equations. All right, and each of these is conveniently set up in y equals mx plus b, or slope-intercept form. And you can see that this first equation, y equals 3x minus 2, is right here. And then the second equation, y equals negative x plus 6, is right here. All right, and what we're looking for is where these two equations intersect. And they happen to intersect right here at the point negative 1,5. That means that point negative 1,5 is true for both of the equations. So just remember that the solution to a system of equations is always going to be the point, the ordered pair, where the two lines intersect. All right. So now we are going to move along and look at what this looks like to solve a system of equations algebraically. Right. So as you can see in this example, I'm giving you 2 equations, and these are equations of lines. And we are going to solve these equations using the substitution method. Now, what I like to do is I like to rewrite my problem with my 2 equations kind of right next to each other. It helps me organize my work. All right, and in step 1, I'm going to choose one equation and solve for a variable. Now, as you can see, if you look at the equation on the left right here, I already have an equation with a variable by itself. So my step 1 is actually already done. Step 2, now, I am going to substitute the equation from step 1 into my second equation. All right, so in my first equation, I know that y has to equal x minus 4. So what I'm going to do is I'm going to take all of this x minus 4, bring it over here, and substitute it in for this y value. So when I do that, I get 4x plus And you see what I'm going to do now is that y value becomes x minus 4. So you can see I substituted right here for this y value with that. And now my next step, my third step, you should end up with one equation, which I have right here, that only has one variable in it, which is perfect. Then what I'm going to do for my third step is I'm going to solve for that variable. Okay, so over here, I would combine like terms. 4x and x gives me 5x. Minus 4 equals 1. I'm going to add that 4 to both sides. Then I'm going to divide by 5, and I get x equals 1. Now, if you remember, the goal of solving a system of equations is to look for that ordered pair. So remember, I want an ordered pair, x comma y. And I just finished finding my x value. I know my x value is 1. What I need now is the y value that goes with it. So my fourth step is to substitute my found solution into that first equation to find the other variable. All right, so what I'm going to do is I'm going to take the fact that I just found x equals 1. I'm going to come back to that first equation and substitute that in. So if x is 1 minus 4, I'm going to get a y value of negative 3. So that is going to come right up here, and it's going to complete my ordered pair. So 1, negative 3 would be the solution to my system. And what I wanted to do here is show you what that looks like graphically. Okay, so my two equations were y equals x minus 4. So I'm going to go ahead and graph that. Got a y-intercept of negative 4, slope of 1. So there's that first equation. I'm going through this quickly because I know you guys know how to do this. My second equation, which was 4x plus y equals 1. I'm going to go ahead and subtract 4x from both sides, getting this into slope-intercept form. And if my y-intercept is 1, slope negative 4, down 4 over 1, you can see here that my lines are going to intersect at this point right here, which is 1, negative 3. And so that confirms my solution is 1, negative 3. All right. Now what I have for you are 2 more examples. Feel free to pause the video at any time if you want to try these without me. I'm going to go through each of my steps. So if you remember step 1, I like to rewrite these equations so that they are next to each other. And remember, my ultimate goal is to find that ordered pair, x comma y. So step 1 was to choose an equation and get a variable by itself. So when I look at this equation right here, I notice that I already have y by itself. So that's perfect. I already have a variable by itself. So my second step is going to take that newfound y value, come over to the other equation and substitute it in, giving me x plus 2 times y. But remember, my y value is 3x plus 2. So you should be able to see that I took this y value, substituted it in for this y value, And you can see that right here. Then my third step is to take this and solve for the variable. So I got to do a little bit of work here. X plus, I'm going to distribute my 2. Combine like terms. Subtract that 4. And then divide by 7. And I get x equals 1. So that is the first part of my ordered pair. Now for my fourth step, I've got to take this x value, come back over to the original, and substitute that in for x. So 3 times 1 plus 2. I get a y value of 5. And that is going to complete my ordered pair. Right. I'd like to do one more example with you. Again, if you feel ready, pause the video and try it on your own. All right, so I'm going to start by rewriting the correct equation, by rewriting my 2 equations next to each other. Again, this just helps me stay organized. All right, if you remember, step 1 says, choose an equation and solve for a variable. Well, I already have a variable solved for right here. So I'm going to choose this equation right here. Then what I'm going to do is I'm going to take, for my second part, I'm going to take what y equals, I'm going to come over to the other equation, and I'm going to substitute that in. So that's going to give me 3 times y. But my y value we now know is 2x minus 3 plus x equals 5. So again, you can see that I substituted what y was in for the y value right here. That's why we call it substitution. Then I just need to continue solving. So I'm going to distribute. And then I'm going to combine like terms. I got 6x and x. Add the 9. Divide by 7. And I get x equals 2. And remember, the goal is to find that ordered pair, x comma y. And I just found that x was 2. Now I got to take that x value, substitute it back into that first equation we started with. So y equals 2 times 2. And this is going to let me find the y value that goes with that x value. 4 minus 3. Y is 1. And there is my ordered pair that is the solution to the system.